This is Yaro Stanchak presenting another interesting video. This is video series 22.0, and what we have here is I put together a different configuration for the motor utilizing the coils from the prior 3-coiler, and what we've done is we've configured it for a 2-coil arrangement. Makes it very simple to pop these in and out and to reconfigure them with different types of coils. The rotor is essentially the same one, being a 6-pole rotor. This particular experiment is a continuation of the 1-wire arrangement in series, and the coil itself is bifiller. We have the bifiller, the second strands, totally disconnected, and we're going to compare it then to the parallel in series arrangement as we've done before. This setup will be in basically in series. See what happens. The expectation here is that we get more RPM because the resistance in the entire circuit has been diminished or reduced from 3.34 or 3.4 down to 2.2. You get more RPM out of it. See how it behaves. Let's get a little bit closer here. That's not bad. We can deal with this. Everything is working fairly nicely here, and this is zero load on it. 0.71 amps, 24 volts, and the RPM is, I've done this test prior, I've got the data written down, just in the interest of timing. The RPM at this particular voltage is 4,442. All we're going to do is add a 600-gram load. And we immediately have a load. The load reduces the RPM. Do a minor adjustment on the voltage so that we're very close. And the voltage is going to stabilize where it's at 24.01. And the amperage will be about 1.32. So we have 600 grams. The RPM at this point is 3,794. So let's jack this up now to 1,000 grams. See if we can stall this. I'm skeptical that it'll happen. Okay, so what has happened here is we've increased the load. The load has been increased to about 950 grams, and you see the readouts that you're getting, that we're getting, and the RPM for now is 3,382. It'll stabilize at about 1.77, 1.76 amps, or a little bit more, whatever. So let's do the acid test and shut this down. And we're going to crank up the voltage to 36 volts. In other words, a 50% increase in voltage. You should see a substantial rise in the initial RPM, and the acceleration rate will be improved. It'll take about 2 or 3 seconds for it to accelerate to full speed. There it is at full speed. Well, it's pretty sensitive here. So, where we're at right now, pretty evident on the screen display, about 0.99, 1.0 amps at 36 volts. You see the screen display is fairly aggressive. RPM. The RPM here is 6,600 RPM. It's motivating pretty well. Let's load it. See that load, 600 grams, really didn't impact things that badly or that much. I do adjust the voltage a bit. The amperage is fairly well stabilized, give or take. It may get up to 1.6 here. Everything is still warming up. RPM at this point is 5,810. So there wasn't that much of reduction in speed with the load. This motor setup is fairly gutsy. Now we put a 1,000 gram load on it. The actual load is about 950 grams. There's some variability there. And we're up at about 2.2, 2.02, 2.03. Things will stabilize around 2, give or take. And the RPM here is 5,313. So 1,000 grams knocks off roughly 1,300 RPM. As I said, this is a real gutsy arrangement. Surprising for people how strong it is. So there you go.